Hey everyone, we're going to learn how to sketch the graph of using our calculator, and I'm using the newer version here, the TI-84 plus C, and yeah, it's probably the version that most of you will be using. Alright, so to sketch a graph on the GC, there are actually a few things to take note of, but it's kind of simple. Alright, to key in the equation of the graph, you click on y equals. There you can see, as you can see, there are 9 graphs that you can actually sketch at one go, but you probably just be using at most 3 or 4. All right. So let's say we want to sketch the graph of ln x, so ln x, and let's say we want to sketch another graph of minus x plus 3. All right. So to view the graph, let's say we have no restrictions on the domain. All right. To view the graph, we click on graph, and then we let it go. All right. To stop any action, click on on. So if I click on on now, it will just stop drawing the graph, right? As you can see. So this on thing button is really quite powerful. Let's say you're evaluating an integral or you're evaluating a differential that is taking way too long time. If you suspect there's a mistake, click on, right? It will break any action. But because I don't want to do that now, there's no error here, so let's just redraw the graph again without stopping. Okay, so as you can see, we have the two graphs here. Now, a few things to take note. If you want to change the axis in a way, like the scaling, like between every point, like every marking or every gap, you can manipulate it from here. So the standard, this is actually the standard settings. So it starts from minus 10 to 10 and minus 10 to 10. So minus 10 from x to 10 from x, minus 10 from y to 10 from x. X scale is basically the gap between the lines. So if now you only have 5 lines each and 5 lines each. All right. But let's just keep it normal and let's just keep going. Okay, let me redraw the graph again. The newer GC is pretty fast actually. All right, so now that you've given the graph, and let's say to calculate some values, you can go to second and then go to trace, basically to access the calc function or calculate function. There are a few things here. So the value basically means finding the value at x equals to a certain graph, right? So let's say on x equals to 5. This for ln x will be ln 5, so 1.6094379. If you want to find x equals to 5 for the second graph, which is the red graph minus x plus 3, you can then click on the arrow down here. These two arrows will then help you shuffle or cycle between the different graphs, not just for the calculate, not just for this function, but also for the remaining functions as well. Let's say you want to calculate the x-intercept, right? Because now 0 means at y equals to 0. So if you want to calculate the x-intercept of the first graph, you leave it as a blue. Find the second one, just click on down. But nonetheless, the idea is still the same. What do you mean by left bound? So left bound means left of the intersection. You want to keep it as close as possible. As you can tell, I have 0.095, that's pretty close. Now right bound means right of the intercept. So I have 0.0588 here, and it's gonna click on that. Then afterwards, click on guess again. By clicking enter, your 0 is x equals to 1 and y equals to 0. Same thing for that. You would also kind of get the same thing as well. All right. Now, minimum and maximum, basically minimum point and maximum point. Same idea, left of the minimum point, right of the minimum point, and you'll guess for you. Same thing for maximum as well. Of course, I can't do it right now because both graphs do not have a minimum or maximum point. Intersect is for two different graphs, right? Or more than 2, I think. Never really tried it before. Now the idea is that you want to get as close as possible to the intersection points on the first graph. So let's say somewhere around here. Then the second graph, you want to manipulate it until it's quite close to the intersection point, and then you click on guess, and you'll tell you the intersection point between two graphs. All right. Now, for the rest 6, dy dx and the integral, basically you can find the gradient, the derivative at a particular value. So if I click on dy dx, and let's say I want the point at this, then it will tell you that dy dx is 0.3. All right. And the same thing for integral. So whoops. Again, it's lower limit. So let's say you want lower limit at here and then upper limit at here, then it will just tell you roughly. But usually I wouldn't use 6 and 7 a lot, right? Neither 3 or 4 as well. All right. Usually 2, 5, and I think even 1 is another way to do it. All right. So these are your calculated values. For your trace, it basically you can just trace along the graph. So if on the first graph you do it like this, second graph click on the down arrow again, and then enjoy the ride. All right. Another thing for our graphs is the idea of zoom box, zoom in, zoom out, right? Basically, if you want to get a clearer view, or you want to expand out or expand in, these are the few things that you need. So zoom 1, 2, 3 are the only functions that you need, along with zoom standard, although I use zoom standard as a reset. So what does each thing do? I'm going to go through zoom in and zoom out first. So zoom in and zoom out, basically, you're just going to zoom the graph, zoom the axis proportionally on both the y and x with respect to a certain point. So in this case, I'll choose the origin. I click on enter, and then you notice it's proportional now. All right. If I were to, let's say, want to zoom out, again, I'll just click on a particular point here, and then I'll click on zoom out. Need not be at the origin, can be at anywhere else. But then again, this is not really a good way to get a closer view for your graph. You would rather much use the zoom box. So what does a zoom box do? Let's say you want to find the intersection, right, more accurately. So you click on the first point. Now you set that point down, right? What you can do is now create a box by manipulating this. And if you want to focus on the intersection point, you can now just create a box that encompasses the intersection point, click on enter, and the graph will then show you where, basically zoom in on the box, and there you have it. You can now find the intersection point better by going to your intercept. All right. To reset everything, to go back to the original graph, click on zoom standard. This will then bring you back to the standard settings, and you'll sketch the graph at these standard settings. Okay. Now, one more thing. This is actually the last part before I go on to parametric and conics for the next video. To add, let's say, restrictions to your domain, because right now, window doesn't really restrict the domain. What you should do is, first, if you want, let's say, sketch a graph of ln x for x bigger than 3 and smaller than 5, non-inclusive, what you need to do is add a divide sign. This divide sign will then become a condition if you add a curly bracket here. All right, so if it's just a divide sign, it's still a divide sign, but if you add a curly bracket, it's now a condition, unless you use a function. So what you need to do is, to add that particular condition, you have x between 3 and 5. However, you cannot just straight away write down like normally x bigger than 3, smaller than 5. You have to break it down to x bigger than 3 and smaller than 5, right? So this is one of the limitations in your GC. As such, to assess the inequality signs, go to second, go to math. It's under your test. All right, so as you can see, there's an equal sign, not equal sign, bigger than, equals, smaller than, and smaller than, equals. We want x between 3 and 5, non-inclusive, so x bigger than 3. To add the next condition, add a divide, again, curly bracket, x. Now go to test, now you want smaller than 5. All right, so smaller than sign, 5, and the same bracket. And now you will be able to sketch the conditions, just x from 3 to 5. Okay. One more thing, because you're not going to include x equals 3 or x equals 5, you have, when you sketch the graph in your graph paper or in your answer sheet, you have to add an empty circle at both ends to indicate they're not including the two ends, right? 3 and 5. All right. So that is it for our calculator, how to use a calculator for GC. I'll be moving on to parametric and conics in your GC as well. But just to give you a taste of what this condition does, just x bigger than 3, you notice that it will just sketch from 3 all the way to positive infinity. All right, so yeah, there we have it, the first part of our calculator on graphing.